All right, thanks for coming by. My name is Mike Place. I am one of the engineers on the core dev team, so I'm one of those elusive guys that gets to write open source code for a living, which is really, really wonderful. And in this talk, we're going to talk, I guess, about top secret SaltStack plugins, which was a topic which was assigned unto me, but basically what I took it to mean and what I want to go over basically are some of the darker, lesser known areas of Salt. Some of these are lesser known because they're not as documented as well. Some of them are lesser known simply because they got written by a person who had a more or less specialized use case that we said, oh, okay, well, we'll include that in Salt, and hopefully somebody else will find the same use case. And some of them just don't get as much attention as things like state.highstate, for example. And so, one caveat of that, one thing that I learned as I was preparing for this is that when you look at parts of any code base, which are not used very much and don't get a lot of attention, they tend to have a few bugs. So the chances of one or more demo fails here is non-zero. But we'll try and make our way through, and if nothing else, hopefully we'll at least cover the main concepts. So I want to talk a little bit about what we're going to go over. The first thing is that, as you've probably heard, or if you've used Salt a bunch, right, Salt is designed to be highly pluggable. And the other day, Tom and I were sitting around in his office, and as he likes to do, he challenged me to a bet. And he said, name every plugin system in Salt. And I said, okay, that's hard. And I'm like, okay, well, let's see. Modules, states, returners, right, like grains, and I'm going on and on. And how many, just out of curiosity, because I'm sort of interested to see if people know the answer to this or if they're anywhere close, how many individual pluggable systems are there in Salt right now? Anyone guesses? More than two, yes, correct. More than 5? More than 10? More than 20? Yes. That's individual execution modules, right? We're talking about plugin systems, things like grains, returners, right? We just cleared, well, let's see, actually. It was 21 the other day, and then we just added engines yesterday, so I think that makes 22, right? Which is a lot. Find me later, when we're having beers, and we'll see if we can go through and name them all. I won't do it right now because it would be super boring and I would look kind of dumb. But the point being that we're going to talk about some of those pluggable systems that don't get a lot of attention either because they're old, or in the case of beacons, which is my next point, because they're very new, right? So we're going to cover beacons. Beacons are something we're extremely excited about. And then we're going to look at a couple of the systems which don't get as much attention. First, SDB, SaltMod, some of the lesser known functionality that's in SaltUtil, some of the stuff that's in the state.py execution module. We all know state.highstate, and we mostly know state.sls, but there's a lot of other stuff in there. And then finally, we're going to look at the test state. And then after that, I'm happy to answer any questions about this or about anything else in Salt in general. Okay. This actually says 30, so that's actually wrong. But you can use as many or as few as you like. Pluggability, right? We more or less went through all of this. Though there is one thing to say about this, which is that it's actually really easy to develop new plugin systems. And if that's something that you're interested in doing, contact the mailing list. If you have a new idea for some generalized functionality, really what's interesting is if you look at the engine system, which is an entirely new plugin system for Salt, does anybody want to guess how many lines of code it took to put in that entirely new pluggable system? 500, up, down, down, 200, down, up from 50. Yeah. 100 on the nose is the answer to that. And so it should not be intimidating to add a new plugin system. Okay. So the first thing that I want to talk about are beacons, okay? One of the things you're going to hear a lot of developers, a lot of people at Salt talking about this week and in the future is an idea that we call event-driven infrastructure, right? This idea that just like we've had event-driven programming for many, many years, because Salt has this wonderful high-speed event bus, that you can use this event bus to stream data onto and to react to make your infrastructure adaptive and reflexive and all kinds of really nice things. So beacons is the first major thing that we've done to try and move toward this new vision. So here's what a beacon is, okay? A beacon is something that does nothing but look at the state of something, right? And then conditionally emit an event onto Salt's event bus, right? Do we all have at least a generalized understanding of what the Salt event bus is right now? Anybody know? Okay, it's okay if you don't. I can explain it real quick. Anyway, that's what a beacon does, okay? We're getting beacons into 2015.2, which is at RC2 right now, so, which reminds me that I have to do my continual push to please test RCs. Like, you don't have to test them in production, right? But when you test RCs, you help yourself, you help us. Please test RCs. Anyway, 2015.2 is in RC2, and beacons are going to be in that. So beacons can be used simply for monitoring, but the real power in something like a beacon, right now we have, for example, iNotify, right? So an iNotify beacon would watch a file or directory on a file system, right? If that file changed, it would fire an event, okay? Then we have a concept called the Salt Reactor. I think most people are familiar with it, but I'll explain it real quick in case you're not, okay? The Salt Reactor is a pluggable system, right, that runs on the master, okay, that listens to events, right, being received by the master, right, and can filter and execute, right, particular states, right, if it sees matching events, okay, right? So this should start to come together, right? Now we have this idea of beacons, okay? A file changes on the file system, on the minion. Minion fires event. Master sees event. Master has a reactor that is configured, okay, to say, oh, in the event, right, that you hear this event, right, fire off a warning, okay? Do some sort of security remediation, right? Shut down this minion because the world is on fire, right? Like whatever it is, okay? But beacons are your way that you can start to generate those events, okay? And beacons, in my view, are most powerful when they're tied to external systems, right? There's absolutely nothing, right, that prevents you from connecting to the Salt event bus directly, right? Literally, you can write a little Python shell script that connects to the Salt event bus and listens or pushes events onto that bus in 50 lines of Python or less, right? Probably like 15 or less if you were super aggressive about it. But what that does is that this idea of beacons that are consistently like emitting information based on particular thresholds, you can tie these into your continuous integration system, for example, right? You can use beacons to make your external systems adopt the same sort of asynchronous nature, right, that Salt itself uses. Does that make sense when I say something like that? So, beacons, that's my pitch for beacons, which I think are awesome. I didn't put a slide in on this because, basically because we added this code yesterday and I forgot. But there is another side to this idea of event-driven infrastructure that we've just added. And because we're touching on lesser-known parts of Salt, I'll talk about it now. This new idea that we have just started to put in is called an engine. So you'll see this, coming out in the docs, right? I think we're going to get it into 2015.2, which is a little terrifying, but it looks like it's going in. Engines are long-running processes, okay, which can run on the master, which can, but are not necessarily, things like pure Python reactors, okay, right? The idea is that you can have this additional customized long-running master process, right, that has access to all of the understanding that the master has, right? So you can write pure Python. So instead of having the reactor, which right now is basically a mapping between event type, right, and the state system, right, which is all fine and good, right, or the, basically the remote X system, but most people use it for the state system. Instead of doing that, you can write pure Python, right? You can speak up and down the stack, right, to, your external systems, what have you. And so engines are going to be an extremely powerful way to consume those events and react to them in sophisticated ways. So we're very, very interested in seeing additional community development around engines. And please come and find myself or Tom at any point later this evening, and we will talk your ear off about engines and why we think they're the future of everything.
Will that involve beer?
Sorry?
Will that involve beer?
I can't hear you, I'm sorry.
Will that involve beer?
Will that involve beer? Yes, that will involve beer. Yes, a considerable amount of beer, right? Though no beer was consumed during the development of engines. I can testify to that. Oops, is that right? Okay. Actually, while we're doing beacons, let's look at a couple, okay? Can everyone see this all right? Okay, we don't need to dim the lights or anything, okay? All right. Okay. Now, one of the things that's really, really wonderful about beacons is how insanely simple they are to write, okay? I wrote one on the plane the other day. Here it is, okay, right? This is a beacon to emit system load averages, okay? Here's all you have to do to write a beacon, right? All of this is optional. This is boilerplate Python. This is boilerplate Salt. You probably know Dunder Virtual, okay? You need one function. You need to call it beacon, and it needs to accept a config, right? Where a config is a data structure, right, contained in the minion config, okay? It needs to do some things, right? In this case, it reads proc load average, and it needs to, right, return a ret, right? Normally a list of dictionaries, okay, right? That's it. There is no more to scroll down to, okay? So what this is going to do is it's going to allow you to do a config like that, right? In your minion, specify some thresholds, okay? If those thresholds are exceeded, it starts firing events. Is that something that you want to see in action, or do you believe me and want me to move on? Okay. Do it. Okay, let's see. Okay. All right. Oh. All right. Let's see, I probably had a master's running somewhere. Let's try this again. Okay. Okay, actually, before we do that, okay. As you can see here in the minion config, right, I do have a beacon configured. It's called load, right? And it has a couple of thresholds, okay? All right. Let's go ahead and start our Salt minion. Okay, all right. And let's see if we can drive load up. Boop-a-doop-a-doop. Load is increasing. Oops. All right. Actually, I probably should have turned my thresholds way down because this machine is too fast. Let's see. Let's do this. Okay. Okay. Actually, let's kill this interval. Okay. Okay. And let's do the number of seconds between evaluations of that beacon. The default for that is 1 second currently. Yeah.
Can you go in milliseconds, basically, or is that?
Technically, we could. The problem with that is that as soon as you put too much load on the minion, potentially you're going to start to block, the listening process, and that would be problematic. So one of the things that we can look into doing, I think, is going to be a dedicated beacon process on the minion. We've talked about that. That would be how we would end up solving that problem. So it's a completely solvable problem, but it's not a solved problem, right? Okay. All right, let's make sure this guy is happy. Okay. Okay. Actually, let's do this. Okay. I'm going to run this in trace mode, right? Okay. That is its polar timeout running, right? So that is the actual beacon loop that's happening, all right? Okay. See if we can drive load up high enough. Okay. All right. And it should be the case now. Oops. Yeah. Ah. Apologies for that. I've actually now completely killed this. Sorry about that. Okay. Okay. One of the things we can do here is one of the ways to monitor the event system, especially on the master, is to do salt run state.event. For reasons that are a little bit unclear to me, that particular beacon is not firing. I will come up with a better demo later. I'm not completely clear why that's not firing. Apologies for that. That's supposed to be firing. Anyway, apologies for my demo fail there. That's what I get for running my demos off of the develop branch. But at any rate, you can configure beacons, right, and they will emit events, and then you're off to the races there, right? Come find me later, and I will correct my demo fail for you in person. Okay. But instead of messing around with that, let's actually move on to SDB. Okay. SDB is a really seldom used part of Salt. Okay. I believe SDB stands for Salt Database or something along those lines. Okay. But it's a system for external data stores on the minion. Okay. It solves sort of some persistence concerns, right, about a minion state, right? So for example, you can put into a state file, right, a call to the SDB execution module, right, to put a key and a value, right, into a key value store, right, and then later on you can retrieve it, for example, right? So that works really well for state persistence or persistence between state runs, for example, right? It works well, yeah. Yes, on the minion, right? Okay. And so it solves a lot of those problems about trying to come up with some sort of like temporary external data store. Now these can be really, really simple. They can be things like SQLite, I think is the one that is most commonly used, right? Because you just get a really lightweight key value store that just sits right there on the minion, right? Or SDB, can actually go out. We've got a couple of, Okay, here in SDB, right? CouchDB, right? There is a keyring DB, right? If you want to use an encrypted data store, right? Or Memcache, right, is an excellent use case for something like this, right? So SDB is a really powerful system. What you can do, actually, the interface to it is via an execution module. Whoops. And typing is hard. All right. Called, surprisingly, SDB, right? Okay. Obviously, we've all used execution module in this room, right? And the interface should be very unsurprising, right? SDB, right? You use an SDB profile, right? Which is your configuration, right? In your minion config. We'll look at that in a second, okay? And then the key that you want to store, right? So get, set, and that's it, right? It's a getter and a setter with an external data store, okay? SDB is only used if you specifically enable it and choose to use it. Do you guys use that internally? We do not, no. So all the, we'll take a little bit of a tangent for a second to answer this question. This question was about whether or not this is the system that Salt is using to do its caching internally, right, via grains caching or what have you, right? No, all of that stuff gets serialized and stored to disk. It's very simple to look at. It's a var cache salt, right? That stuff, I think, most of the time gets message packed serialized, right? So it's really easy. To the best of my recollection, the code that does that is in salt.payload.py. So if you want to pop open a Python shell, what I'm saying is if you want to examine one of those cache files in Salt, pop open a Python shell, load up whatever class it is, I forget off the top of my head, in salt.payload, right? And you can start to deserialize those quick as a whistle, right? Any other questions? All right, on SDB. I wanted to show you the SDB config real quick, right? Oops. Okay. Right. Okay. There it is at the top, right? Okay. That's all you need, right? Something that looks like this. MySQLite, right? A driver, right? These options are specific to the SQLite SDB interface, a table, and an option to create the table, right? From there, it's all call -- local, right? SDB.set, SDB. Let's see, what did I call it actually? No, I forget. Okay. Okay, I think I called it SQLite. Okay. Oops. Takes 2 arguments. Oh, URI and a vi. Right. Where'd that go? There we go. Okay. Ta-da. nothing special in a demo like this, but imagine incorporating this into your state files. You know, there are many, many use cases for using this type of system, and it doesn't get used very much. So it's a nice thing to have. Any questions before I move on from SDB? Oh, pretty simple. Okay. All right. SDB plugins, I should mention, just like other plugins, are exceedingly easy to write. You know, so if you want to, you know, if you have your own data store, if you have Couch or, you know, whatever you want to do, writing one of these plugin systems is as easy basically as wrapping your connection to your database and a getter and a setter, and you're done, right? So we would love to see more contributions in this area. Okay. Okay. So one of the areas that that I think people tend to find kind of complex about Salt is the requisite system, right? I think it's pretty fair to say that the learning curve for that can be kind of high, right? And one of the things that we hear a lot is, especially from people who are coming from other configuration management systems, is why don't you have something like Chef's, you know, test kitchen or what have you, right? Why don't you have some way in which I can model my states? And recently, we've added exactly that, and so I want to show it to you. And I want to make the case that this is a really nice way to prototype what you want to build before you go out and build it, right? Because obviously you don't want to, you know, develop, right, against the actual live state of a load balancer somewhere. That would be, you know, bad, right? So we have a really nice way to do this, right? Okay, and at this very moment, we are going to go play around with it, okay? Okay. So one of the things that I want to mention before we do is that especially if you're a little bit new to Salt, one of the things that can be a little bit tricky to understand is the difference between the execution module layer and the state management system, okay? The best way to understand that is that when you call, you know, salt star foo.bar, you are always calling in to an execution module, okay? One of those execution modules happens to be called state, okay? Super important distinction, right? Yeah?
So the plugin model of execution modules is actually a composite type plugin model, meaning you have a plugin model of the plugin models?
No, not exactly like that. The point is that Salt is fundamentally a remote execution engine, okay? But there is a state system, right, which you can interface with, right, using a remote a execution module on the other end of that remote X call. Does that make sense?
Well, just like SDB, for example. It's an actual, they're calling an execution module.
Right.
That executes the plugin model itself. The SDB plugin model.
Okay. I've got you. Yeah. Yes, you're getting it right. If you go back, actually, the question was about this relationship between Salt plugins, right, and Salt execution modules, right? If you, we'll just take a quick trip backwards for a second here, right? Let's look at, this, right? Sorry, I apologize, I'm in the wrong place, okay? Here's the SDB execution module, right? You see that this is literally a wrapper, right, around the plugin system, right? Which in this case is Salt Utils SDB, right? Which then goes out and evaluates back into Salt, right, SDB, SQLite, and then you're off to the races. Does that relationship make sense now? Okay, great. Yeah, an adapter would be a really good word for that. Yeah. Okay. Okay. Actually, I apologize. apologies for that. What I want to look at here, okay, is, okay, not there. It is here, okay? Okay. So, again, the question that we're trying to answer is how do I model, right, my requisites for the state system? So one of the things that we added to try and solve this problem is the test module, right? It's actually, I'm sorry, it's a test state, okay? So it's not in the modules directory, it's in the state directory, okay, right? And so what this allows you to do, right, we won't have to get too into it, frankly, because we don't really have the time, because I've gone in a couple of different directions. But it allows you to do stuff exactly like this, right? It allows you to model requisite relationships by calling things like test succeed without changes, test fail without changes, so on and so forth, right? And so you can see here, actually, right? Here are fail with changes, fail without changes, right? Succeed with changes and succeed without changes are the big four. Any question? Yes. Yes, that is an excellent point. For those of you who didn't hear, I think the point fundamentally was that you can use this both just to model, right, but also really in production, right, as a marker to ensure, right, that state runs have actually completed. Yeah. Right. Everybody hear that? And right. Okay. Yeah. So point being, right? I don't think I need to go in here and model requisites because this isn't a tutorial on how to build states. But the point being, if you get confused, right, about how to build requisites, I really recommend using this to do so. I think I made an example, if I remember correctly. All right, that we can just look at, all right, real quick, right? Here's something, here's a nice way to use that test system just to model this sort of thing, right? None of these, I don't think, right? No, none of these are actually, states that go out and do things on systems, right? It's the state system modeling itself, right? So doing that, right, okay, I will, let's see, I will kill this so that you can see this, right? I will kill this. I called this demo test state, right? Right. You can see here, right? Oops, apologies for that. You actually get the whole requisite map, right? You get what would have happened. So it's really nice to sort of use this as a rapid development tool, and then you can translate this onto your infrastructure that you're actually trying to control, especially if you have complex requisites. Do you have any questions about this or what it's used for or how you might use it? It's pretty straightforward. I just find that it doesn't get used all that often, so I like to evangelize for it, right? Okay, how are we doing on time? Looks like we got about 10 minutes, is that right? Okay, all right. Is there something that people are dying to hear about that they're going to be disappointed if I don't cover it? No? Okay. Okay. The queue system built by our friend Utah Dave, sitting right over there, right? Hi, Dave, right? Queues are a system to enqueue data using the queue runner, right? And then later on, right, in your deploy process or whatever it is, you can pick up that data by simply processing the queue to translate those queue items, right, into events on the Salt event bus. Dave, do you want to tell us a little bit about what prompted you to include this functionality?
One of our customers had a system where they could completely re-image their server and repurpose it to another class of application. They wanted to do that fairly quickly.
Mm-hmm.
But it was better to do it with. It was better to do it more than one at a time. It was more resource intensive. You know, it saved resources to do like 5 at a time or 10 at a time. And so we were using the reactor to do that, but the reactor does them 1 at a time. So the deal with the queue was that they had another application that would decide that they would need to move these servers over, and so they would generate, pop the minion ID onto this queue, and then every hour they would process this whole queue at once. So that would build up. Actually, I think they would check every 10 minutes, and if it got to 5, it would just go ahead and do it. Otherwise, it would just run it once per hour and process all the minions in that queue and move them to the new image that they need to be running. Right. So something, it was also an idea that it could also be, this is accessible through the runner system, so you can view the contents of these queues and how many that are there. So they wanted to have like some graphs on their dashboards. So if the queue had 10 or 15 or 20, that was within reasonable bounds, but suddenly it was like 10,000. It's like,
right.
Stop. So
Right.
it's kind of like a relief valve for the reactor, because the reactor does stuff right away. The queue can give you the possibility to make sure things are sane before things happen.
Right. Thank you, Dave. Did everybody hear that? And does anybody have any questions about the queuing system and the way you might use it in your own deployments or how it works? Okay. All right. I apologize for rushing because I want to get to a couple of these concepts, and by all means, I'm more than happy to talk about any of this with people in depth. So please accept my apologies for rushing through a lot of content, but these sessions are very short. I want to talk a little bit about MasterTops because we get a lot of questions about this, especially when it comes to transitions between configuration management systems, right? So we know what top files do, right? Top files provide a mapping, right, between sets of hosts, right, and intended states for those hosts, right? Normally we create those top files, by hand in serve salt, right, top.sls, right? But it turns out that that top system is in itself pluggable, right? And not only is it pluggable, but you can call out to external systems to generate a top file for you. And that when you do so, that will get merged into the top file that you have. One classic example for doing this is with Cobbler, for example, right? I was actually going to set up a Cobbler demo and then Cobbler, right? And that just became way too complex way too quickly. But I can show you like a really basic example. I think I still have it up here. Okay. So basically what I did is I built myself a little fake cobbler, right? Okay. We need to do here is hopefully that pull from develop finished. Oh, it did not. That is unpleasant. Check out YAML top. Okay, there it is, right? So the MasterTops system, right, is here in this directory called tops. You can see that we have out-of-the-box integration with Cobbler, right? You can store your top file data in Mongo, right? We have actually a really neat system called Reclass, which doesn't really get a lot of credit. But Reclass allows you to use object orientation and class-based approaches and so you get like the power of inheritance and all these sorts of things to create your top files. So reclass has actually been in there for quite a while. And for purposes of this demo, which I'm going to have to rush through, I just added YAML.py, right? So let me show you, right? Right, so super easy, right? Yeah, you can see where I copied and pasted something. But this is super simple, right? But the idea being all we're doing is we're calling out to an external web service, right? Loading up some YAML and then returning it, right? And we're deserializing it in exactly the same way that a top file would look if we serialized it, right? Does that make sense, right? So if you have an external web service, right, or any type of like external data store, you can use it to generate your top file data. First, take questions, and then if we have time, do a little bit of demo about this. Do you have any questions about the MasterTops system in general, or any Salt-related topic that I can try and help with? Yeah.
Where would the line be to tell it to use this YAML by
Okay. That would be in the master config. Okay, let's see. These two guys right here. Okay. If you look in the documentation for MasterTops, this is documented pretty heavily how to use the existing MasterTop plugins as well as how to write your own. And frankly, by looking at the code I just showed you, you should see that it's exceedingly trivial to write your own, right? And then here, of course, I just, in the top file plugin that I wrote, right, I just put in a little URL there, okay? Right. And so, okay. One of the things that we didn't even really get a chance to see, right? Right. Oops. All right. Oh, that's not it. There it is. Okay. Yep. State.py. Okay. So let me run a master and minion again. Okay. There we go. Hopefully, I actually do have network connectivity at the moment. And there's my second demo fail of the day. I'm not going to be able to reach out to an external server because network. So I also apologize for that. But let me just, again, show you the config and how it would work, right? That's salt, right? Right. Again, all you need to do is declare the external sources of truth, provide any sort of configuration information, and that external tops file will be merged into any sort of local top file that you have. So I'm just about out of time. Are there any additional questions? Hopefully we provided at least a light overview of some of the darker corners. And like I said, I'm happy to take questions later on and go into any of this stuff in more depth if it's helpful to you. If there are, yeah?
How often does it pull a new top file?
Anytime that it needs to be generated, right? So, yeah, anytime top file is generated, which usually happens on high states. If you look at state.py, not the execution module, but the one directory above that, you'll see the high state class, and in there's a method, I think, called generate tops or get tops, something like that. So anytime that gets hit, yeah. Yeah? Yes. Okay. The question was whether or not you could have multiple external sources, and the answer is yes. Yeah? Right. I believe that is first one wins, but I would want to double check on that. But that's my recollection, is that first one wins. Yeah. Any other questions? Okay, there was a lot we didn't, oh, I'm sorry, please. Thank you. That's very kind. Anyway, like I said, there are 22 of these things now, and we covered like 3, so I could do probably 2 straight days on pluggable systems in Salt. So please come find me because I love to talk about this stuff. So thanks very much for coming.